Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. I am welcoming you all to this beautiful online learning platform. We are happy to announce that now we are going to providing online training for GATE and engineering service exams. So now you can use this facility. You can crack GATE and engineering service with India's largest learning platform. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for GATE exam. At present, I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. Here you check how to get Unacademy learning app. Just go to Play Store, type Unacademy, and it will show the Unacademy learning app like this. By clicking on this install button, it will install the Unacademy learning app into your device. Now, what you will get? See, by joining Unacademy, what you will get? See, first you have a daily live classes, of that structured courses, live tests and quizzes, and unlimited access. So in daily live classes, the intention behind to conduct everyday live class is always to keep the student in touch with the subject. So in this daily live class, student can chat with your educator, that means your faculty, and engage in discussions. You can go for discussions and you can ask your doubts and answer polls. What are the polls conducting here? You can answer those polls also. So you can perform all these things while class is going on. Next, structured courses. All our courses are structured in line with your exam syllabus to help the students best for their preparation. Okay, what are the syllabus we have? That syllabus is well structured and proper in a well organized manner. Then it is very easy to the students. First, what subject has to complete, after that which subject, after that which subject. Okay, live tests and quizzes. So to evaluate your preparation, so you can evaluate your preparation with our regular mock tests and quizzes and get the detailed analysis on your performance. Okay, you can evaluate your preparation with your regular mock tests. Regularly we are conducting mock tests and quizzes. Okay, so you can evaluate your performance by participating in this regular mock tests and quizzes and get the detailed analysis on your performance. Next, unlimited access. So once you take in a subscription, one subscription, you can get access to all our live and recorded courses to watch from the comfort of any of your device. Once you get a subscription, you can access all our live and recorded courses to watch from the comfort of any of your device. These are the things you will get by joining Unacademy. So there are two subscriptions, iconic subscription and plus subscription. In plus subscription, what are the things? Just before I explained: daily live classes, structured courses, live tests and quizzes, and unlimited access. All these things you get in plus subscription. Okay, next, in iconic subscription, what are the benefits got by the plus subscriber? You get all the benefits got by the plus subscriber. In addition to these benefits, you get few additional things. They are: personal coach, study tracker, mains question and answer practice. In personal coach point of view, you get one-on-one guidance from top exam experts as your personal coach. You get one-on-one guidance, one-on-one guidance from top exam experts as your personal coach. So once you've written the test or you attempted an assignment, sorry, quiz, that paper is analyzed effectively by your personal coach. See that personal coach is the exam expert. Okay, he analyzed that paper. Based on that, they will prepare a proper study plan to you. Your For every individual student, we are assigning one personal coach. Okay, he take care about that particular student only. Okay, based on this analysis, they will provide personal study planner as well as respect to study material to that student. Okay, next, study tracker. So in study tracker, by participating in study tracker plan and study booster workshops, you can evaluate your progress in by weekly reviews with personal coach. By weekly reviews with your personal coach. Next, this is very important thing, mains question and answer practice. In engineering service exam, you need to answer the mains question. Okay, first you need to see the way how you are answering the questions in semester exams is different from answering the mains question in engineering service. Okay, you should know which in topic, in respect to question, which topics has to be highlighted. Okay, and which equations has to be included, everything. So you can get that from what you can practice more here. You need a regular practice. So you can strengthen your mains answer writing through regular practice with evaluation and personalized feedback. So regularly you need to practice it. Once you've written that some question, you answered some question, that is going to be collected and forward to the expert. He is going to evaluate it and give some personalized feedback to you. That feedback is very helpful to you, okay, to strengthen your mains question and answer practice. Okay, these are the benefits you got from iconic subscription. Next, yeah, so there's Unacademy combat is once again back this April month. Also in March, in the month of March we have one combat. Now in the month of April also we have one combat. The worth of this combat is 3.5 plus crores. Okay, this is on every Sunday in April. 4th, 11th already completed. Now it is turn of 18th of April, tomorrow. Okay, and next combat is on 18th and coming Sunday. So enroll now and use my code VRAO10 to enroll this during enrollment. Okay. Now these are the different departments. Here are the different departments. For these departments, exam is a scholarship test is going on. Mechanical, civil, electrical engineering, electronics and communication, and computer science and information technology. Okay, exam is on every Sunday at 11 a.m. Duration is 60 minutes. Okay, 1 hour. And top 3 winners get the 100% scholarship on plus subscription, and 100 winners from each department will be given additional discounts. Don't forget to use my code to unlock the exam. Now these are the things you get by attempting this. India's largest weekly scholarship test it is for GATE, and you can assess your GATE preparation in 60 minutes. Challenging and original GATE questions curated by the best educators. Okay, and take it live to compete with the best. Super fast and fun with All India Live Leaderboard. Identify and improve your weak areas through detailed video solutions. Okay, and exam is on Sunday 8:11 a.m. Don't forget. So here are the GATE 2021 rankers who benefited from GATE combat. Previously what we conducted combats. So these are the rankers from GATE 2021. They benefited from that combat. Now we are going to problems on transistor amplifiers. Previous sessions we done some problems. Now I'm going to skipping that problems. Already we solved a few problems. Okay, now I'm going to directly where we are. What are the next problem? Already we solved all these problems. This is the last problem what we solved. This is the last problem what we solved. Okay, yeah, so this one also solved. Yeah, next see this problem for the emitter current, sorry, for the emitter follower. The emitter follower is nothing but a CC amplifier. CC amplifier. Okay, circuit given below. For that, calculate IC DC collector current if beta is 100 and they given VBE is 0.7. After that, you need to find voltage gain, current gain, input impedance and output impedance. So this is your CC amplifier. Okay, we check this now. First, we take the DC equivalent of this and calculate the IC DC first. Okay, now I'm going to take the first DC equivalent circuit. Now this is the DC equivalent circuit. Capacitors are open circuited. And the given VBE value. They given 0.7. 0.7. So this is 8 kilo ohms and it is plus 12.7 volts. Okay, now first I am calculating base current. Regular procedure I am following. IB. This is IE. Just applying KVL to input loop. By applying KVL to input loop, so KVL to input loop, so 12.7 equals to IB into 100K plus 0.7 plus IE into 8 kilo ohms. So we can write IE as 1 plus beta times IB. Beta they given as 100, so 101 times IB, and this is a 101. Now IB is written directly 12.7 minus 0.7 by 100k plus 101 into 8, so 808k. So this is the IB value. Now just calculate that. 12 divided by 908k, 908. So that is 13.2 microamperes. So once you get the IB, now go to IC. Beta times IB. Just into 100. Okay, now into 100 by 10 into 10. That is 1.32 milliamperes. That is the DC collector current. Once DC collector current is over, we need to calculate the voltage gain, current gain, input impedance and output impedance. Now I am taking the circuit. Here you connected in AC analysis, whatever the capacitor here we have, that one is short circuited. Vs they given. So here they are taking output 8 kilo ohms. It is 12.7 volts. Now I am going to taking its AC equivalent circuit. AC equivalent circuit. For AC equivalent circuit, it is DC supply connected to ground. DC supply connected to ground. Capacitor is short circuited. Now in this, collector is connected to ground. Base is connected to ground through 100 kilo ohms. And at base, input Vs is applying. And at emitter is connected to ground through 8 kilo ohms. And at emitter taking the output. These are the credentials. Now I am going to rearranging this transistor. Collector connected to ground. Emitter connected to at emitter taking output, and at base giving input, that is base is connected to Vs. At the same time, base connected to ground through 100 kilo ohms and collector connected to ground through 8 kilo ohms. These are the input and output voltages and AC equivalent of the transistor. First of all, now we need to replace your transistor by R-Pi model. Why? Because they did not, in that given data, they did not given any information related to H parameters. Once you calculated DC collector current in this sense, from that you can derive everything. That means R-Pi you can get, transconductance you can get. Okay, now replacing this transistor by R-Pi model, and your R-Pi model representation of transistor is like this. Is R-Pi so emitter, this is a GM into VBA, small VBA, and it is collector. That's it. Now I am replacing that one here. Collector connected to ground. Collector is connecting towards ground. Collector is connecting towards ground. output side we have emitter, input side you have RPi base. It is base. After that, I'm giving additional connections. At base, collector connected to ground. At base we have 100 kilo ohms, and this is our Vs. Similarly, at output side, at emitter we have 8 kilo ohms. So these two currents should be entering into this. This is a GM into VBE. So this is the collector current IC. Okay. Or you can write beta times IB also, no issue. Now, so here taking output VEC or output. This is the VBE. And this is the input voltage VI. Is nothing but a Vs. Now I'm copying this circuit for further reference. So this is our circuit. So I'm going to calculating one by one parameter. First of all, I'm writing VBE. So VBE is VBE is IB into RPi. After that, I am going to writing IC. IC is GM into VBE. This GM into VBE is IB into RPi. Okay, and by applying KCL here at node A, you can get the value of IA. By applying KCL at node A, we get IB is entering, IC is entering, plus IE also entering, equal to 0. Therefore, your IE is minus of IB plus IC. Okay, just substitute the values. By substituting IC value, that one here, you get, it is minus of IB into 1 plus GM into RPi. That is IE. Now I'm going to calculating one by one parameter from this data, and first of all we need to calculate GM and RPi from this data. So GM is IC by VT. IC is just before we calculated 1.32 milliamperes. 1.32 milli by, I am taking it is 25 milli. So it is 1.32 by 25. It is 52.8 milliamps per volt. Next I am going to calculating R pi. R pi is Vt by DC base current IB. So it is 25 milli by base current already we calculated, that is 13.2 microamperes. 13.2 micro. So 25 by 13.2. It is 1.89 K. That is R pi value. Okay. Now I'm going to calculating IE from this. So for that, both should be multiplied. GM into R pi is 2.8 milli into 1.89 K. Two point eight, that is 99.79. For easy simplification purpose I am taking it as 100. This is the given data which is available to us. Now analyze this circuit by using a regular procedure. Now first I am calculating current gain AI, which is minus IE by, this is IE sir, minus IE by IB, but I minus IE is IB times 1 plus GM into R pi, just before we written, by IB. So it is 1 plus GM into R pi. So GM into R pi already calculated 100 it is. So 1 plus 100, 101. After that, input impedance Ri, which is input voltage by input current IB. So input voltage is VBC, VBE, voltage between these two, plus voltage between these two. Voltage between these two terminals is nothing but a between emitter to collector. Output voltage, that is VEC. Now I am writing VEC. VEC is, this is IE, it is minus IE. Minus IE times 8K. So that is a VBE plus VEC by IB. So VBE value is IB into R pi, IB into R pi plus VEC is minus IE into 8K by IB. So now just simplify this. IB by IB gets cancelled. Now it is R pi plus minus IE by IB is AI into 8K. So just we calculated R pi value, that is 1.89K plus AI value 101 into 8K. So that is 8K. So total it is 808 plus 1.89, that is 809.89K kilo ohms. That is the RI value. Okay, see, and one more thing, this is your RI you calculated between these points except biasing resistor, but they clearly they given VS. This is your required value of RI, but we are calling it as RI dash. Therefore, RI dash is RB parallel with RI, and this is your RB. So 100K parallel with 809.89K. So it is divided by 909 909.89, that is 89 kilo ohms approximately. That is your RI dash. So this is your required input impedance. Okay, not this. This is the impedance, input impedance at between the transistor terminals, but including biasing resistor. This is the input impedance. This is the input impedance of the transistor. It is the input impedance of the amplifier. Okay, now so AI is over, RI is over. Now we go and calculate voltage gain. This is IE, it is IB. Now, okay. Now we need voltage gain. Voltage gain AV is already we derived. It is VEC by VI. VEC is minus IA times 8K by VI is IB into RI, input impedance. So this is nothing but a current gain, AI into 8K by RI. So AI 101 into 8K by RI value. Input impedance is 809.89. 809.89K. So that is 808 divided by 809.89, that is 0.999997. That is the voltage gain. Okay, so these are the things they asked in the problem. So we move to next problem. So this is clearly, it is a CE amplifier. So it is a CE amplifier. Now first find the IC/DC, and if beta is infinity, and what is the voltage gain. See, simply we can write voltage gain. There is no H parameter given. DC collector current they given. You need to calculate. So once you know the DC collector current, means it should be in a R pi model. GM transconductance, sorry, voltage gain of this one should be minus GM into RL dash. Here RL dash is, let us take it as RC, it is RL. So where RL dash is 1K parallel with 1K, that is 0.5K. So transconductance voltage gain is minus GM into 0.5K. That's it. Just to calculate GM. What is GM? We know that IC by VT. So minus IC by minus IT by VT. VT into 0.5K, and we know the value of VT. Okay, so just you have to calculate the base current of this. Okay, and first we need to take the DC equivalent circuit. I'm going to take the DC equivalent circuit of this. DC equivalent circuit. This is the DC equivalent circuit. It is a 1 kilo ohm, 1.3 kilo ohms it is. All capacitors are open circuited. At the same time, they given beta is infinity. Beta infinity in this sense, you have to take IB approximately 0 and IC is approximately IE. By applying Thevenin's equivalent at input side, already in biasing we solved this type of problems. Now you get it, Thevenin's equivalent at input side and RB Thevenin's resistance. Now output part is as usual. So 1.3 kilo ohms it is. 1 kilo ohm, it is 6 volts. 4K, 2K, now it is 6 volts. Okay, now voltage at this point is 2 volts. Just by applying case voltage division rule. Now it is 2 volts. And the base current is approximately 0. IB is approximately 0. And here you get IE value. This is 0.7 VBA. Now simplify. Just apply the KVL to input loop. So by applying KVL, you get 2 is equals to IB into RB 0 equal to 0.7 plus IE into 1.3K. Therefore, from this IE is 1.3 by 1.3K. That is 1 milliamp. So which is approximately IC. Therefore, IC value is 1 milliamp. Take that and substitute in that. So what is the voltage gain you written? So our voltage gain is minus GM into 0.5 KRL dash by VT 25 millivolts. So GM already we've written. GM is mod IC, sir. Sorry. So GM is a IC. IC by VT. Now just substitute this value here. It is a 1 milli into 0.5K by 25 milli. So it is 0.5 by 25. .02. Okay. Okay, it means 20 minus 20. That is the gain. So voltage gain is minus 20. That is a problem. So next one is transistor in the circuit is biased at a DC collector current of 0.5 amperes. Okay, clearly they given DC collector current, sir. They did not give any H parameter. And at first level of problems, everything in terms of DC H parameters. But now they are not giving any DC currents, any H parameters. DC collector current we are calculating. From the analysis of knowledge of DC collector current, we are going to calculating everything. So DC collector current they given as 0.5 amperes. Okay. Once it is 0.5, from that you get GM immediately, IC by VT, 0.5 amperes by 25 milli. So 0.5 by 20 it is 0.02. Okay, so that means 20 amps per volt. That is the GM value. Okay, This is the CA amplifier. It is clearly emitter is connected to ground. That's why it is a CA amplifier. So for CA amplifier voltage gain, we know that minus GM into RL dash, where RL dash is RC parallel with RL. It is RC, it is RL. So which is 10K parallel with 10K. That is 5 kilo ohms. Now substitute values in that. Therefore voltage gain is minus GM into RL dash minus 20 into RL dash is 5K. Okay. So it is minus 100K. That is the voltage gain. Okay. See, you are getting gain is very high because the given DC collector current is high, 0.5 amperes. If it is in milliamperes, now there is no K here. Okay, that is the difference. Yeah, see this problem. Here they given the beta value and you need to find input impedance and voltage gain. See emitter here they given and IE they given. This means it is the DC emitter current. The given DC emitter current IE 0.5 milliamperes. 0.5 milliamperes. Okay. Now we need IC. So IC is beta by 1 plus beta times IE. We know that. Just get the IC from this. 100 by mostly you get 0.5 approximately. Not 1 into 0.5 milli. So it is 0.99 into 0.5. 0.49. So it is a 0.495 milliamperes. See 0.5, 0.495, not much variation. So you can take approximately 0.5 milliamperes. That is the DC collector current. Once it is over, now immediately go to transconductance GM, which is IC by VT. 0.5 milli by VT, 25 milli. Will cancel. 0.5 by 25. It is 20 milliamps per volt. That is the transconductance GM. Okay. And RL dash. This is CB amplifier. So it is CB amplifier. For CB amplifier, voltage gain AV is GM into RL dash. We know that already we done this analysis. Now this is RC and it is RL. So RL dash is RC parallel with RL. Sorry. 10K parallel with 10K. It is 5K. Substitute the values. So it is 20 milli into 5K. It is 100. That is the voltage gain. Voltage gain is over. Okay. And they want the input impedance. Okay, input impedance. So input impedance of this one is between emitter to base we have R pi. So this is R pi and input impedance Ri is R pi. What is R pi value? So R pi is simple, capital IB by VT. Get the IB from this. So that for IB is, I'm going to next slide. So R pi is IB by capital VT. DC collector current. IB is a DC base current. Therefore, IB is IC by beta. 0.5 by beta is 100. Okay. Now it is 5 microamperes. That is 5 micro by 25 milli. Okay. Now sorry VT by IB, sir. VT by IB, sir. So now it is 25 milli by IB is 5 micro. Now it is 5 kilo ohms. So it is IC by VT. Okay, fine. This is the input impedance, sir. So like that, once you know the procedure and you analyze the amplifiers thoroughly, then you can easily substitute the values in that. No need to do any analysis. So far we solved nearly 20 plus problems. In all the problems, just at only one problem we replace the transistor by its R pi model. Remaining things directly we are applying because we are familiar with that, and we are converting the circuit convenient to our standard model. Now see this, here they given a PNP transistor. Okay, and emitter connected to ground. See, emitter is, you observe one thing, at base they are applying input, and at collector they are taking output. So emitter connected to ground through capacitor. Under DC analysis, capacitor is going to be short circuited. So it is CE amplifier. CE amplifier, no doubt at all. Once it is CE amplifier, they want input impedance and V0 by Vi. V0 by Vi. Now the input impedance here you are getting is R pi. The input impedance you get R pi, including RB you need to get, that is RA dash. Okay, and they given IE value. Beta is 200. So they given IE value, DC emitter current 10 milliamperes. Now because of beta is 200, approximately it is also IC. Okay, you get nearly 0.98 something. 0.98 something you get. IC value 0.98 and 10 milli, not much variation. Sorry, 9.8 and 10 milli, not much variation. Okay, this is approximately IC. So far we know the IC value from this. Okay, and just immediately go and calculate transconductance GM. GM is IC by VT. 10 milli by 25. 10 milli by 25 milli is 10 by 25. That is 0.4. So that means 400 milliamps per volt. That is the GM value. So once we know the GM value, and here they given only RC. So voltage gain is minus GM into RL dash. But here RL dash is only RC. That is 100 ohms. By substituting we get AV is minus 400 milli into 100. Okay, that is 0.4 into 100. 40 minus 40. That is the voltage gain. And input impedance is they want. The input impedance RI is between these two terminals. RI is R pi. It is R pi. and but we need including biasing resistor, Ra dash, and Ra dash is 10k parallel with R pi. First get the value of 10k parallel with Ri. This is the required one. Now get the R pi value. R pi is Vt by Ib. Okay, Vt by Ib. Vt is 25 milli by Ib. So Ib is Ic by beta. We know that. Ic is 10 milli by beta is 200. Cancel. So this is 0.05 microamperes. Sorry, milliamperes. That means 50 microamperes. 50 microamperes it is. IB is 50 microamperes. Now take that and substitute here. By simplification, it is 50 micro. 1 by 2 it is 0.5. It is 0.5 kilo ohms. 0.5 kilo ohms. That is Ri. Now 10k parallel with 0.5. Approximately 0.5 you get. Okay, that is the Ri value. See this, how simple. Once you are familiar with that basic equations, how easily we are going to solving this. See this another problem. They given a beta value 100, find the voltage gain, and Vt they given. See, first from this you need to calculate the DC current. I am taking the DC analysis. It is 0.7. Okay, and this is the emitter current, IE. Under DC conditions, your capacitor is open circuited. So this is the KVL. Now IE value we get 10 minus 0.7 by 10k. That is 9.3. 0.93 milliamperes. 0.93 milliamperes. That is the equation for value of IE. So beta is they given nearly 100. So once beta is 100, IC and IE we can take approximately equal. Otherwise, if you want IC, that is into 0.93. 0.92 you get. So IC is 0.92 approximately milliampere. See, not much variation. 0.92 milli, 0.93 milli, not much variation. That is IC value. Okay, and get the IB also parallelly. So IB is 0.92 by 100. Okay, it is 9.2 microamperes, and IB is 0.92 microamperes. Okay, now I am going to calculating one by one. First trans conductance I am calculating, IC by Vt. So IC value 0.92 milli by Vt 25 milli. 0.92 divided by 25, that is 36.8. 36.8 milliamps per volt. And R pi Vt by Ib. Vt value 25 milli they given by Ib value 0.9 micro. That is 27.7 kilo ohms. Okay, so you need to calculate V0 by V input. Okay, so that is For it is a CB amplifier. First of all, for CB amplifier, voltage gain is V naught by V input. You need to calculate. See this, V naught by V input. Here is your input, but we are calculating up to this. This is let us take it as Vx. Under AC circuit, it is short circuited. Under AC, it is short circuited. Okay. So let us take it as Vx. Now voltage gain is let us take V naught by Vx. Vx I am calculating. Okay. So once we calculate up to V naught by Vx, it is Gm into RL. Okay. So Gm into RL. RL is 5K. So 36.8 milli into 5K. $184. That is the gain. This is from here to here. Okay, but here is your Ri dash. This is your Ri. Here you get Ri. It is Ri dash. Okay. And this is Rs. Including Rs you need to calculate. That is AVS you need to calculate. It means the required voltage gain is AVS, which is V naught by V input in this problem. Okay, now we calculate that. Therefore, AVS is AV into RA dash by RA dash plus RS. Here RI is R pi. Already we calculated, it is 27.7K. Ri dash is R pi parallel with that means Ri parallel with Ri parallel with this value is 10K. 10K. Now it is 27.7. It is 277 divided by 30.7. That is 9.02. So approximately 9 kilo ohms. Now substitute this value. You got it as 184. It is 9 by 9K by, it is 9 plus RS value is, RS value 100 ohms. 100 ohms means 0.1K. Okay. So now it is 9 divided by 9.1. 9 divided by 9.1. That is 0.98 into 184. That is 181.9. That is the gain of the circuit. Okay. So like that you can solve the problems on this. So hardly we have a few more problems. Next session we go on complete those problems. So hardly 3 problems. Next session we go on complete that. So here are our top educators, few of the top educators from Unacademy. Tiwari sir, he is IIT topper and he has 7 years of GATE and engineering service exam teaching experience. And he is the author of a book, GATE in 75 days. Ankit Goyal sir, he obtained All India first rank twice in GATE electrical and he was awarded President of India Gold Medal in IIT Indore. Jaspal Singh sir, he is ex-IAS officer. He got 4th rank in that and he is the ex-senior faculty from GATE ESE. Jaspal Singh sir is the computer science faculty having experience more than 8 years. Here are a few more top educators from Unacademy. So these are the different engineering disciplines available in Unacademy. ECE, chemical engineering, mechanical engineering, computer science and IT departments, instrumentation, electrical engineering, civil engineering, production and industrial engineering. So there are two plans, plus plan and iconic plan. In plus plan, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. The same thing here also, but once you attempted an exam or quiz here, that is forwarded to your personal coach. Your personal coach is do the personalized test analysis on that. Based on that, they prepare personal study planner to you, and respective study material also they will forward. By following these two, every student can get success in their examinations. Plus plan. In plus plan, it is available in different subscriptions: 1 month subscription, 3 months, 6 months, 1 year, 1.5 year, and 2 year subscription. And the beauty is here EMI option also available. Okay, and by using my code VRAV10 during subscription, VRAV10 during subscription, you can get it by 10% discount. Okay, so it is, if you take 1 year, it is a 30,250. By using my code VRAV10 during subscription, you get it by 10% discount. After discount, it became 27,225 rupees only. Next, iconic plan. It is available in two subscriptions, 1 year and 2 years. For 1 year, it is 50,250. By using my code VRAV10 during subscription, you get it by 10% discount. After discount, it became 45,225 rupees only. Okay, don't forget to use my code VRAV10 during subscription. Hit the bell icon, subscribe us, and join our Telegram group for getting latest updates on our upcoming videos. And please give your valuable comments on YouTube. And once again, I am welcoming you all to this beautiful online learning platform, Unacademy. And I am thanking one and all for spending your valuable time with us.